All right, so as Sujata said, my name is Gerald Rogers. I'm a principal engineer in the Network Products Group at Intel. So today I'd like to discuss DPDK and Cloud Native, kind of looking at some of the things that we're looking to do for Cloud Native applications and what we're looking to implement within DPDK in order to help facilitate Cloud Native. So if you look at the beginning, right, we started out with NFE, based, in a lot of initiatives with Etsy NFE. And the main objective there was to look at how to improve CapEx and such by looking at COTS platforms and trying to move networking workloads onto standard COTS or off-the-shelf platforms. This enabled many different things, including, flexibility to assign VNFs to hardware, rapid service innovation, and reducing OpEx. So a lot of efforts over the past, probably 6-7 years have been looking at how we can utilize virtualization technology and build networking applications on top of within the NFE framework. So now that that's started to progress and take a lead inside of the industry, there's now some initiatives to look at how cloud and cloud applications can be applied to the telecommunications networks. And so if we break down and we look at Cloud Native and its impact, the goals of Cloud Native is to decompose and it's both applications and infrastructure, move to a more stateless environment so that less state is maintained at any given time. Today, a lot of applications maintain state about the session or a flow that traverses throughout the network. In Cloud Native, a lot of the state is not maintained at any particular node or with any given instance of the application. It can be distributed throughout the data center itself. Very rapid life cycles, right? So one of the advantages of cloud, and if you look at a lot of cloud companies, is the ability that they have to quickly deploy new services, to quickly make changes to the application and push them out. Continuous integration, very robust testing infrastructure. Those kind of things is what cloud is trying to offer, right? So very quick changes and improvements in the services that you can offer. So, scalability, right? So instead of being bound to a particular node in taking could be weeks or months in order to deploy and scale out your infrastructure in a telecommunications network or in your general networking environment, being able to quickly scale up or scale down is the advantage that cloud offers you, right? It's what the Googles and the Facebooks of the world have achieved is the ability to quickly scale a service across their data centers, and that's kind of the objective that we like to see happen in telco or general networking environment as well. Lightweight, so the applications become lighter. Instead of a lot of dependency in knowledge of the underlying hardware or the underlying platform, the goal is to, what cloud applications kind of do is they abstract up to a higher level. So there's less knowledge of the platform in a cloud application. And so they become lighter weight, more portable throughout, and more portable. And it's not just the application, but also trying to push both the infrastructure and the application in these directions to try and improve the robustness and deployability of new services throughout the telco environment. Okay, so that's kind of like the impact. That's what's happening, what we're trying to achieve. So if we go back and we kind of look a little bit at the history, right? If you go to the left side of the picture here, you kind of started out many years ago with, that's where networking was. It's customized hardware, it's specific achieves a specific function, and everything particularly came from a single vendor. The goal of NFV was to kind of move it away from, at least from a hardware perspective, to a more standard platform, and that's what NFV achieved, and virtualized the services so that they were easier to deploy throughout the network or throughout your data center. But the framework and the services, they still remained as a proprietary implementation, right? So the first step in NFV really was take an existing hardware appliance and the applications that ran on that hardware appliance and just really virtualize them onto a COTS hardware. And that's been successful. It's deployed very well. Now moving to a more intermediate stage before cloud is looking at things from the perspective of making them cloud ready, right? So instead of a virtual machine being all from a single vendor, in other words, the services that are infrastructure that's within the virtual machine or container from a single vendor, you now move to where you have a sort of mixed framework. And the mixed framework would be, could be part of it is custom or proprietary to a particular vendor, but really trying to produce frameworks that are, introduce frameworks that are generic and such that the service or the application that's there can utilize these frameworks that are more generic and be more portable across different types of cloud infrastructure. And finally, when you go into cloud native, right, the underlying hardware remains the same in terms of COTS and you move to an environment where containers or pods are the underlying base framework or the base infrastructure that's offered to the service. And then an open framework, an open standard framework that the service actually uses. I guess an example would be something like gRPC or something, a higher level communications mechanism, so that the underlying whatever transport that's there, the application doesn't need to be aware of it. It will operate at a higher level, making it more portable across different environments. So that's kind of where we're trying to move things. We're kind of mostly at NFV today, and that's great. It works great. It's deployed widely, but there's some movement and interest in going towards cloud ready and cloud native. So we're looking at things that we can do within DPDK in such to get us there. Okay. So if we kind of step back and look at a service mesh concept, if you're familiar with Kubernetes and such, they already lay out a kind of a container framework in how to lay out and deploy your services. So as an example, a service could be something as very simple as an IMS, instant messaging system, that gets deployed within a container environment. And so what gets defined in that kind of environment is a pod or a collection of containers. A services could be running within that collection of containers. And then another little concept that kind of gets thrown in is what we call a sidecar. A sidecar is really a service proxy, is kind of what our view of it is. And you can use that sidecar as a way to allow the containers to connect to the outside world or provide a service. The sidecar really is providing, it acts as a proxy. And the proxy could be a proxy to the outside world in terms of like the platform and the underlying protocol infrastructure for that platform. Or it could be a security proxy, as an example, in terms of determining how two different pods or two different containers are allowed to communicate with one another. So there's different things that the sidecar can achieve. Wow, why does it keep doing that? It's doing it up here too. So anyhow, so that's kind of, and with service meshes, right, not only providing a mechanism on a single node, but also on how you scale across different nodes in the infrastructure. Okay, so given this as a base concept, trying to look at it, what we're trying to put in DPDK or actually add into DPDK to help with this base concept. So what we're looking at is DPDK view of cloud native, right? Is that you still have your standard applications or containers. They could be a virtual machine, could be based on a container itself. You have a DPDK host, and it could be DPDK host based or container based, which is this little box. I wish I had a mouse here. Here in what we call it in terms of creating a trusted sidecar. So and then you still have your standard native DPDK applications that run at the host. So what we're looking at is how we can improve DPDK to act as a trusted sidecar. So developing a base reference or a solution for a DPDK trusted sidecar. So this would allow runtime dynamic orchestration, so improving DPDK for runtime knowledge, gathering the services, improving DPDK configuration and manageability. That's kind of what we're looking at from that level. Support both virtual machines and containers. It's both Sidecar or VM or native host applications. And of course they have access. We're not restricting anything per se, in the sense that you have to go through a DPDK sidecar. Every application, whether it's in a virtual machine or host-based, still can access hardware as they need. So the goal here is to add into DPDK the sidecar to provide the services to the other applications. In other words, to create a proxy for the services running in containers to communicate with other services and also the base infrastructure of the platform itself. Okay, so that's kind of what we're looking at in terms of adding into DPDK for cloud native. Okay, so what is a DPDK trusted sidecar? Okay, so from a sidecar functional, right, is applications or containers. They need to somehow connect to the outside world, right? So looking at the outside world, the virtual machines can connect many different ways. They can connect on VirtIO, they could connect on SIOV as an example to the outside world. What DPDK provides is a great framework for abstracting a lot of that out, right? And so what we would like to look at is providing inside of DPDK the configurability and manageability of the underlying hardware infrastructure to act as a sidecar for virtual machines and applications to communicate to one another. So we're looking at a product that, well, it's actually part of DPDK today as a separate application. It's called SummaryPatch Panel as part of this trusted sidecar. In utilizing the DPDK knowledge of all the different hardware interfaces, such as NICs, Quick Assist technology, virtual Ethernets, MIMIF, VirtIO, in such a way that all these ways to connect virtual machines to containers, virtual machines and containers to the outside world, DPDK can act as the underlying framework to abstract all of that out and allow the application to work at a higher level. And that's what we're looking to do, right? So there's, and then the sidecar will provide the, connectivity between the different platform services that are running on the platform. So what are we looking to add into DPDK? There's primarily three different things. First is a runtime coordination. We kind of call it runtime coordination. We're trying to think of a different name for this, but runtime coordination, a higher level abstraction layer, API, and also some improvements to the SummaryPatch Panel. But what is the DPDK runtime coordination is one of the things we're looking at is how is it better to orchestrate DPDK. If you're familiar, DPDK provides a lot of infrastructure, but it was never really built as a complete solution, right? It was primarily built as a framework or a base library that you would develop your own applications upon. So a lot of the ability to go in and look at DPDK base infrastructure and configure things like memory allocations or CPU L-core assignments or assigning a NIC to DPDK dynamically, doing these things kind of dynamically was really never built into DPDK. You could do it within your application. So like when you built your application and deployed, it was capable of doing that. But what we're looking at doing is adding in a library, which we're right now calling runtime coordination. And this would be built based on a fuse file system, or basically a user space file system. So what we're looking to add into this is that all the underlying DPDK EAL layer, there are a lot of different parameters there that you can use to configure DPDK. Most of them are static today and built when your application is either launched or such. What we're looking to do is add this library API into DPDK that creates a fuse-like file system. So if you're somewhat familiar with Linux prox file system or Linux sys file system, this is actually very similar to that in the sense that the application, as well as the underlying EAL layer and some of the other layers of DPDK, will mount into the file system different things that you can change and improve or modify, basically. And so this is a way that the orchestration can come in and actually control and program and change the underlying configuration of DPDK dynamically, right? So it's trying to add a little bit more dynamic behavior to DPDK that hasn't been there to, and what we're looking to push into the DPDK environment, okay? So, typical file system operations get set, and write, read is what's being built into this, okay? So the next is what we call a service. It's kind of like an application abstraction layer. What we're trying to do is abstract out some of the more complex aspects of DPDK. So, some of these would be it's kind of just try to make, some of them would be like macros as an example, instead of you having to write down at the lower level of DPDK APIs. Some could be macros, some could be new APIs to bring up a little bit higher level the application's knowledge of DPDK or required knowledge of DPDK. So in essence, DPDK, the application would need to have knowledge of what's an RTE L-core as an example. We would abstract that up a little higher so that it's just, this is just a thread as an example that's running. And the DPDK just has to be, the application or service just needs to be aware of a thread executing. It's just a generic thread instead of, what the heck is an L-core, right? That kind of concept, right? So, and then abstracting out some of the other devices, to make them easier for the application to use. So really just to hide the nature of the hardware. If you look at DPDK, it's very the application becomes knowledgeable of the hardware more. And the goal is to kind of bring that level up a little bit more than what's already in DPDK today. And then there's the last piece that we're looking at including is software patch panel. Now, there are a lot of different frameworks that have been put in place for DPDK to try to build out a pipeline. Right now, an example, there's a couple of them that have been there for a while in DPDK. One other one that's kind of recent is what was in FFGo, and it's really Golang based in terms of trying to build a pipeline in DPDK. Software Patch Panel doesn't try to build a pipeline, but we started this probably about 2 or 3 years ago. is when Software Patch Panel was started, it kind of lingered for a little bit and wound up, but it is on DPDK repository. But it's really more, Software Patch Panel was designed to be a higher level DPDK resource manager, right? To really manage the DPDK resources and provide a management interface. And so it'll act kind of like the underlying framework that we'll put the fuse onto in order to manage the DPDK resources. So it kind of like centralizes, the original concept of SPP was to centralize the DPDK resource management. And if you're familiar with DPDK, it has a client-server model. And SPP was kind of based on that whole primary, secondary model for client-server. And so you create a primary application that controls all the resources on the platform, and then all the secondaries are assigned resources from that. Now, we won't take it to that level where you were forced onto a primary, secondary model, but using the same general concept of SPP in the sense that you have a single entity that's kind of managing the underlying infrastructure resources. And then the application doesn't have to be a primary, doesn't have to be a secondary, it can be another primary. And then allowing SPP to provide the connectivity between all the different primary applications. And that's kind of what, so you'll have a component of the application, whether it's running in the container or running in a virtual machine, that has SPP in it. And from there, you can actually assign the interfaces that component is allowed to use, right? So for instance, a virtual channel or a MIMIF or such, it could be created utilizing this base infrastructure. And so that's kind of the other thing that we're looking to add into this trusted sidecar. So to kind of summarize, we see that cloud native is an emerging solution space. There's been a lot of requests and interest in moving towards the cloud and cloud deployment models, primarily for ease of deployment and quick, rapid changes and such. We created a great foundation with DPDK in the NFV space. And so we want to build on that success that we had with NFV and improve DPDK for cloud native. So we're looking at adding some new APIs, Fuse file system, service abstraction layer, as well as kind of repurposing SPP to make it more applicable to the cloud environment. Create a cloud native sidecar to facilitate container interaction with physical devices. So try to bring DPDK, since it's very well knowledgeable of the platform itself, try to take and make a trusted sidecar proxy so that the remaining services can actually use that. And basically create a trusted proxy for containers and virtual machines to interact with other containers in the outside world. And that's what we're trying to look at going forward with DPDK and Cloud Native. Thank you.